Hey everyone, we're gonna go over our chapter 7 review now. Especially if you missed class for whatever reason. Let's see if I can get it. All right, so our first question is 2 to the x is changed to d of x 1/2 equals 1/2 f times x plus 3 minus 6. How is the graph transformed? So we're gonna identify our a, h, and k. So a is 1/2, h is -3, k is -6. So this tells us that we have a vertical compression by 1/2. -3 tells me we go left 3. And -6 tells me we go down 6. You can also do this by graphing it, but you would only be able to see these two transformations. It's not going to be as obvious that it is compressed by 1/2 when we graph it. So it's easier to identify the A by actually knowing A. So again, as always, pause the video as needed. Okay, next we have question number 2. If f of x equals natural log of x is changed to g of x to f of x minus 2, how's the graph transformed? Again, we're going to identify a, h, and k. Again, as always, a is in the front, so a is 2. H is 0, k is -2. Any background noise you hear is courtesy of 7th period, not following directions of having headphones in. Since h is 0, nothing actually happens with it. A is going to be our stretch, so this is a vertical stretch by a factor of 2. And then -2 tells us that we go down 2. Okay, question 3 asks us to simplify using the properties of logarithms. And we do note that all answers should be in log form. It does say to use the properties of logs. So luckily on your formula chart that you do get on the ACP as well as your test, we do have our properties. We have product property, which says that we can condense by multiplying A and B here. We have quotient property that says we're going to divide A and B. Power property that moves the exponent to the front or moves the multiplier to the exponent position. And then we also have change of base, which we really didn't talk about much in class because your calculator lets you pick your base. So we did not talk about that as much. So going with these, here, I'm going to use quotient property because we have a minus sign here. So we're going to do log of 72 over 2. And 72 divided by 2 is 36. Here we're going to do product property because we have a plus sign. We're going to do log of 12 times 6. And 12 times 6 is 84. We're going to do product property again because we have a plus sign. So I'm going to do log of 9 times 4, which equals log of 36. And on this last one, we're going to do power property. So we're going to move this 2 to the exponent position. So we get log of 6 squared. And 6 squared is just 36. So that's multiple ways you can actually get 36 as an answer. What property of logarithms is shown? So this question is actually designed to make you look at your formula chart because we just want the name of it. So whichever one we looked at earlier, again, we said moving to the front, this would be power property. Again, this question is actually truly designed just to make you look at your formula chart. Moving on to question number 5. What value of x makes the equation 5 to the x plus 1 equal 125 true? So we have 5 to the x plus 1. We're going to rewrite 125 in base 5, which would be 5 cubed. And so we would now, since our bases are the same, we drop them and we just have our exponents equal to each other. And we're going to solve. So to get x by itself, we are going to subtract 1. So we get x equals 2 for our final answer. Right, number 6. Layla invested $1,600 in an account that pays 5% annual interest compounded monthly. What will her balance be after 2 years? And use the formula A equals P times 1 plus R over N to the NT. So just like on this, I give you the formula. On your actual exam, we will also give you the formula. So there's a couple things to remember. P stands for the initial or the principal amount. R is my rate as a decimal. N is the number of compounds. And T equals time. So how many years? So in this case, P is going to be 1,600. R is 5%, which would be 0.05. N is going to come to how many times a year? So how many months in the year are there? There are 12, so there are 12 compounds. And then time is after how many years? So T equals 2. So in this specific problem, all you have to actually do is plug it into our formula. We have 1,600 parentheses 1 plus 0.05 over 12 raised to the 12 times 2 power. And we are just going to go ahead and type that into a calculator. So we're going to type that here into Desmos. So we're going to do 1,600 parentheses 1 plus 0.05 over 12. Close my parentheses. Shift 6 to get to my exponent. And we're going to do 2 times 12 is 24. So you can either do 2 times 12 like this, or that like that, I'm sorry. If you want to actually do anything in the top, you do have to put parentheses. So you can say times 12 like that. Or hopefully you also know that 2 times 12 is 24. And we do get our answer right here. We are going to round to the second, to the 2 decimal places because we're talking about money. So my answer is going to be 1767.91. For our final answer. But for the most part, this one is they just plug it into the calculator and tell me how much it is. All right, for our next question, for question number 7, we're given a number of key features. That says our domain is from 0 to infinity. Our range is negative infinity to infinity. There is no y-intercept. We have one x-intercept. We have no symmetry. There's no min or max, but I do have a vertical asymptote at x equals 0. What parent function has a graph with these key features? I'm going to give you a hint and let you know, we should remember that we're in a certain topic, so it's probably one of those. If we take a look at our notes, and we'll find I have 2 options. My answer is either going to be log of x, or it's going to be natural log of x. These are the only 2 that have a vertical asymptote at x equals 0. And so that's when we would have our vertical asymptote here. And they both look something like this, to that extent. Where again, we have a cutting point on our x values that we can't be negative on either of those. But whenever we have this, especially on a unit test or anything like that, or even on your ACP, think about what equations we've used in that testing period. So like this wouldn't be a quadratic, it wouldn't really be a cubic. There's certain hints based on when you're testing to answer this question. But log or natural log would be our answer for this one. Question number 8, what value of x makes the equation 9 to the x equals 27 x to the minus 1 true? So for these, we have two options. We can either solve using logs, or we can do common bases. And I'm going to go ahead and show both. So we're going to go ahead and do both versions. We're going to do common basis first because that's the one I think of doing first. 9 is really 3 squared. We still have it raised to the power of x. 27 is 3 cubed, and we still have that exponent of x minus 1. Our base is the same, so we bring them down. We have 2x equals, we distribute that 3x minus 3. So I'm going to subtract 3x from both sides. We get negative x equals negative 3. So divide by negative 1. X equals 3. That is one option. The other one we have is using logs. So I can take log of both sides. So this would be log of 9 to the x equals, now this is not the method I would use, but it is what it is. Log of 27 to the x minus 1. Yeah, I wouldn't do that method now I'm looking at it. I really wouldn't. That's ugly. Wouldn't do that method now that I see it. I would do common basis. Don't do logs. If you do big logs, that's just making it really messy. Moving on to question number 9. What is the equation of the asymptote for the function? So this is an exponential function. I can spell exponential. You know, maybe I can spell, maybe I can't. We should know this is a, b, the x minus h plus k. Y equals k is my asymptote. So in this case, 3. If you cannot remember the method, that is fine. What we're going to do as a backup is you can also graph this one, because some of you are able to actually see it when you graph, especially if you've been doing your homework where they've asked you to identify them. Okay. So if we go ahead and graph our asymptote, this function, which would be parentheses 1 divided by 2. Close parentheses raised to the x minus 1. To get that minus 1 in the front, you are going to have to, or in exponent, you have to do parentheses for that part. Otherwise, Desmos will automatically push you down, and then plus 3. So when we zoom out on this one here, we can see how it's bottoming out right here. That's ironically the same color. You can see how it's bottoming. It's getting a flat bottom. That's where my asymptote's going to be. Whereas this curve here is it's going to keep going out the further, even if I zoom out. So zooming back in, we'll go home. You can see right here that's touching. But I can also pull up the table. Make a table. Starts at 2. And if you just start hitting enter, you can see that they just keep getting really close to 3. That even if I put, I don't know, 700, eventually it just tells you 3. So if I do 800, it's just going to say essentially it is 3. So y equals 3 because it is flattening out instead of it's a horizontal. And all horizontal lines are going to be y equals. If this is a multiple choice test, I suggest that you also go about with finding my mouse. If you graph them, if you're not sure if it's an x equals or a y equals, graph the two options that you like. I know it's one or the other. Graph them and you can see the difference. And we can see how the red line, which is the x equals, isn't the line I need. Next, we have what is the logarithmic equation form of the equation e to the x equals 31 to 85. So remember, anytime you have e, you're going to use ln. So in this case, e to the x, actually we normally have it as e to the y equals x is the same thing as natural log of x equals y. So you should see that these two are going to switch sides is what should happen. So I'm going to take natural log, natural log of 3185 equals x is my answer. When we do natural log, I don't have to write base e. I will say technically if you do log base e of 3185 equals x, this is true, but it's not going to be a multiple choice question answer. If they ask you what is the best answer, this is my best answer. And sometimes remember on those exams, they ask what is the best answer. You want to go with the natural log here. And that's what we should always associate with E. What is the exponential form of the equation? So actually I'm going to put that back up here. So with an ln, you need to remember that it's going to be base E. So we're going to have E and basically x and 3 should switch sides. So e to the third equals x is my exponential form. Moving on to question 12, and we're almost halfway done. What value of x makes the equation log base 7 of 3x plus 1 equals log base 7 of 2x plus 9 true? So one of the things we're always going to check for is if the bases are the same, it makes everything really nice. They have both base 7, so we're going to set the insides equal to each other. We're going to do 3x plus 1 equals 2x plus 9. And just go ahead and solve for x. So I want x by itself. We're going to move 2x to the other side. And at the same time, we're going to move that minus 1 to the other side. So the 1's cancel out, the 2x's cancel out. 3x minus 2x is 1x. 9 minus 1 is 8. What is the exponential form of equation log base 2 of 16 equals 3x plus 1? So on this, do recall that log base b of x equals y is the same thing as b to the y equals x. So based on that, we have our b value, our x value, and this entire side right here is my y value. So I'm going to do 2 to the y, which is 3x plus 1 equals 16. Next, we have what is the exponential form of this log? So again, we're going to use that same setup. Here's my b, here's my x, here's my y. So I want b to the y. 5 to the 4 equals x would be my exponential form. Marcus bought a bike for $1,000. The value of the bike depreciates at a rate of 50% per year. Wow, that's fast. What will be the value of the bike after 3 years? Use the formula y equals a e to the k to the negative kt. So y equals my new value. So whatever it's going to be, the depreciated. A is my initial amount. E is E. It's the number. So remember, again, this is going to be a button on your calculator. You should have e to the x on your calculator. That's what we're going to use. K is going to be my rate as a decimal. And then t is time. So they said my initial amount is $1,000. My rate is 50%. So as the decimal, that would be 0.5. If you're not sure what your decimal is going to be, always take the percentage and divide it by 100, and that will give you your decimal that you need. My rate, oh, I had rates, so that's K. I know I used R. E is E, T is time, and it says 3 years. So T is 3. So in the calculator, I would type in 1,000, and then I would use the E button. And then negative, and I'm going to put a negative because it tells me right here in this formula to use a negative. 0.5 times 3. I'm going to go ahead and go over to Desmos for my calculator. And we're going to do 1,000. And I think if you just press the button E, it actually lets you use the letter E as what we're using. So you can either press the button if you're using your school calculator, which is also fine. That works. If you're trying to find the E, they're going to use this button here. So they're just using that as an E. Let me double check and make sure it's not under function. It's not under functions, but if you ever need natural log or log base A, which is your base, you find it under the calculus section. So we're going to just type in the letter E. I'm going to do Shift-6 to get to the exponent, and we said negative 0.5 times 3. And let's see, does it say how to round? It does not tell us how to round. So I'm going to do 2 decimal places. So the new value of this bike after 3 years is only $223.13. So that depreciated part of it. Okay. Next we have what value of x makes the equation 9 to the x plus 1 equals 81 true. We're gonna do, again, this is, you have 2 choices. You can do bases or logs, and this one actually is okay to do both. Common bases to me is the easiest one. You should recognize that 81 is 9 squared. So x plus 1 equals 2. Subtract 1, subtract 1. X equals 1. If you wanted to do log form, you could do this. You could change this to log of 9 of 81 equals x plus 1. Log of 9 of 81 minus 1 would equal X. Which you can type in the calculator and you would also get 1. The choice is yours. I think the common base one is easier to do. I finally figured out how to do the other one in log form. But it doesn't matter. All right, 17. Carmen invested money in an account that paid 5% interest, compounded continuously. After 20 years, the investment, I just realized it doesn't have the word years, S in years. The investment grew to 2,718.28. What was the value of Carmen's original investment? Round to the nearest dollar. So we're going to round to the nearest whole number. We're going to use the formula A equals PERT. P is going to be your principal, so your initial amount. Oh, capital A is my final amount. E is E, R is rate, and T is time. So this time we want to know we're actually solving for P is what we're doing. So we know that it equals 2718.28. I don't know P. It does stay as an E. My rate is 5%, which we already know is 0.05. And then T is 20 years. So to solve for P, I'm just going to divide by E to the 0.05 times 20 on both sides. So remember this right here, this E to the exponent, that's just a number on its own. We just have it, it's just written in a different way. So P is 2718.28 over E. I feel like that's E to the 1. 0. Um, 0.05 times 20. Yes, I am recording. So a couple of features you actually have in Desmos that you can use to your advantage is you can say, like you can set certain amounts to be a certain value. So like A equals 2718.28. We can say R equals 0.05. T equals 20. So then I could just say, well, this is A divided by E raised to the NT. But you do have to keep with the values that you typed. I can't use T, A equals. Why is it? Let's make it okay here. Let's make it, we need it. Oh, this is because it's a decimal. Okay, so I can't use R. That's fine. That should be an R. There we go. So it looks like it was $1,000, but we can also check by just typing this in. What our actual original one was, we said 2718.28 divided by E to the parentheses 0.05. Close parentheses 20. And we get the same thing. So just a different way of typing it in. If you're gonna have to do a lot of them, it's easier to just list your variables, and then you just keep typing it into the formula, and it'll just automatically do it for you. But we're gonna round this to the nearest dollar. So 0.99 becomes $1,000. So she initially put in $1,000, and after 20 years, she earned an extra $1,700 off of it, essentially. All right, question number 18. If f of x equals 2 to the x plus 4, what is f to the negative 1 of x? And we do have a hint. F to the negative 1 of x means inverse. And the other hint we have is this will be a logarithmic function. So just as a review for finding the inverse, step 1 is write it as y equals. Step 2 is switch x and y. Step 3 is solve for y. And then step 4 is rewrite it as f to the negative 1 of x equals. So we're going to start this off as y equals 2 to the x plus 4. So that's step 1. Step 2 would be switch x and y. So x equals 2 to the y plus 4. And step 3, as always, is where all your real math happens. We're going to start solving for y. So we're going to switch this to log form. Log base 2 of x equals y plus 4. And my goal is to get y by itself. So I'm going to subtract 4 from both sides. And we get log base 2 of x minus 4 equals y. Y is by itself, so my final answer is f to the negative 1 of x equals log base 2 of x minus 4 is what my inverse function would be. We have 4 questions left. So we have if f of x equals 2 to the x is changed to g of x equals f of x minus 5 minus 4. How's the graph transformed? So this is again another a equals, in this case, a equals 1 because nothing changed on that. H equals positive 5 because h is opposite of what we see. K equals negative 4. So this means it went right 5 and down 4. And I just realized I should have made one of those at least a plus sign to make me go up, but that is all we have on 19. What value for question 20, what value of x makes the equation 8 to the 2x equals 134,217,728 true? We have 2 ways of doing this. Believe it or not, this is actually what 8 to the 9th power equals. So if I do it in base 8, it actually becomes really simple. This becomes 2x equals 9, divided by 2, and we get x equals 9 halves, or 4.5, depending on how it lets you write your answer in, or if it's a multiple choice. Your other option is to do log form, which would be log of base 2 of 134,217,728 equals 2x, and then divide by 2. Oh, this is not log base 2, this is log base 8. And you would type that in the calculator. And you should get 4.5, so let's go ahead and type that into Desmos. So log, I'm gonna do x8, delete the x, oh, or not. Let me make sure I have this number right. 1, 3, 4. Do not put the commas in when you're typing this in. 217, 728. 1, 3, 4, 217. Oh, 728. I missed the 7. So go back and put a 7. And we get equals 9. So we divide this by 2, and we get 4.5. So those are the two options you have. More than likely, some people would pick the pink version just because you probably do not know your powers of 8s off the top of your head. And that's completely fine. I would not expect you to know 8 to the 9th off the top of your head. So pink is probably the better way of doing it if you don't know your powers or if you don't have a list of powers to look at. But blue is if you happen to recognize that it is a power. Okay, question number 21 is a review question, as in state the degree and the leading coefficient. So as a reminder, the degree is the highest exponent. And then the leading coefficient, which I'm just going to do LC, is the coefficient of the term of highest degree of the highest exponent. So if this was in standard form, which has descending exponents, that's the reason the leading coefficient is the leading coefficient, because that's in standard form. However, in this case, I'm just going to look at my exponents. We have 2, 3, 4, and none. The highest exponent is 4, so this is what I'm going to base it on. So my degree is 4, and my leading coefficient is 7, because that's the coefficient. And it's a positive 7, because this is a plus sign right here. So that's just basic terminology that we should make sure that we are recalling. Moving on to your guys' favorite topic of factoring. What is the complete factorization of x cubed plus 5x squared minus 4x minus 20? Should always do first to last two. The first two's GCF is x squared, so we're going to factor out an x squared. So divide both of these terms by x squared. And you get x plus 5. And a hint is it should factor, so I should want the second set of parentheses to be an x plus 5 over here. So we're always going to pull out the sign that this first one here has. So we are going to pull out a negative. And 4x and 20 both have 4 in common, so a negative 4. So divide these all by negative, both of these by negative 4. And you get x plus 5. Your set of parentheses get me one set of parentheses, so x plus 5. And then the numbers in the front get my second set, x squared minus 4. And I'm going to remind you that they do have a favorite factoring technique. X squared minus, or a squared minus b squared is a plus b times a minus b. And even if you're not going to memorize it, you need to recognize it. Because if you go to the formula chart and I scroll down here, under polynomials, it gives you the formula of a squared minus b squared. And again, that's going to be one of the most favorite versions to use, especially when you see the words complete factorization, is they probably have one of these special factoring techniques built into the question. So this actually ends up being x plus 2 and x minus 2 for that x squared minus 4. And then we have x plus 5. But you do need to recognize the special factoring techniques. Moving on to our last question. We have described the end behavior, even or odd function, and the number of zeros of the graph. So let's start with the easy one. How many zeros? Remember, 0 stands for x-intercepts. So how many times does it touch the x-axis? 1, 2, 3. I don't care where, I just know that they have 3. So I have 3 real zeros. Next, let's talk about even or odd. So we're working backwards, actually, is probably our best, easiest thing to do. Even or odd is looking at these arrows. If they are a pair, meaning they either both go up, up, or down, down, it is even. If they are odd or a mismatch, is when you have one of each. So it is a mismatch. And in this case, it is a mismatch. So it is an odd function. And then for end behavior is we are going to look and see as it goes, as x goes to negative infinity, what does y do? As x goes to positive infinity, what does y do? So as x goes to the left, it is going down. So we are going left and down. And then we are on the, as x goes to the right, we're going right and up. So as we go to the left, down would be to negative infinity. As we go to the right, we are going to up to positive infinity. So that is actually the end of the review. Hopefully that is helpful, especially for those who missed the review. And I will see you guys next time once I figure out how to stop this. There we are. Bye.